All right, folks, if you are able to attend it on your laptop through the Zoom, you can do that. To people who want to relax back on their sofas and watch on the TV, it is being live streamed now. So you can watch from the comfort of your sofa. What I'm going to do is, after observing different teams and thinking what I should do to help you guys, I thought I'll give you some parts of the solution. Remember, some parts of it, not the whole of it. So any questions before I start, or any particular area that anybody wants to ask? Anyone?
I was asking where to save.
Um,
I forget it, man. We anyway pulled in.
okay, guys, I don't hear any questions, so I'll give you the context. See, one of the questions, there are two parts to it. One is, where do I run my AI? Once you have, guys, please mute yourself. Right. Okay. So you have to ask this question. If I write, let's say, any one of the AIPs, however simple it is, let's take the simplest one. Some of you realized that breaking up text into chunks is not as simple as you think. It needs more careful consideration. The brute force way of doing fixed size chunks can lead to a sentence finishing abruptly in the middle of a word or in the middle of a sentence, a context window, or a sequence finishing that way. You could then say, all right, I'll retract a little bit. Either I'll end at the previous sentence or the next sentence or something like that. You can do such simple tricks like that and allow for some degree of overlap between the chunks. That is one way of chunking. The other way you could do is you could say that, all right, what if I look at semantic boundaries, places at which the meaning of the one sentence, what it's talking about, and what the next sentence is talking about changes significantly. You could try that. In theory, it sounds good. In practice, you will have mixed success. There are no perfect ways to do that. It's a very active area of research. And in a way, by asking you to do a semantic chunking, I wanted to give you guys a window into the complex world.
Go to your Zoom.
Guys, can you please mute yourself? Dennis, can you please mute yourself? Yeah. So in this complex world that AI really is, when you try to solve a problem carefully, it gets significantly harder the more you think about a problem. It just is, like people have told me that searching through the documents these days is just 3 lines. Go to Hugging Face or LangChain, 3 lines, you can do it. Yes, you can do it as a proof of concept, and the germs of the solution are there. But to scale it up is a different thing. We have talked about it many times. Today, what I would like to do is take you guys through some very simple sketch of solutions on that front. First, I'll walk through the core idea, and then I will also talk about what are some good practices on hosting it. Is it the right practice that you just run it as a Python code? Should you run it in Flask? I noticed some of you are running it in Flask. What are the considerations that you have to go through? So towards that, I will first start with how I've laid out the directory structure. So
it is audio? Yes.
Yeah. So if you notice, there is a LLM Bootcamp project. I think I will be releasing parts of the solution. Today, I'll release the inference part, maybe one Spark job also I'll release, so you have an idea. The way this code is structured, and I apologize if the fonts look a bit too small, I'll try to increase it in size. Is it reasonably visible on most of your big screens, guys? All of you are sitting in front of large screens, I believe, in your different conference rooms. Anyone? Yes, yeah. Okay, so I'll start with something very simple. I have the comments, which basically contains some basic IO aspects, like, for example, saving a model and loading a model, right? And the ability to do that in such a way that I mean, just some basic utility, I create special data types instead of using str for classifier. I tend to use for URL. I've created some types, Python types, URL, classifier label, classifier name. You don't have to do it. These are all sort of, think of it as syntactic sugar. Exceptions, it is always a good idea to have some, have your own exception classes. I have a few exception classes. My root is the SV error, and then you have the missing arguments error, unspecified directory, because quite often, people may launch your job without specifying the directory in which you would find data. It is helpful if you throw a specific exception named after it, unspecified file error, things like that. So some very basic things, right? And then one of the things I notice that people keep doing that, and I've been walking from room to room, and I notice this very common, is that people do OS, or open file and so forth. Defensive coding says that you should not presume anything. Before doing anything, and I would, if I may say that, a good practice is to have preconditions and post conditions. Before you do anything, ask, under which circumstances should I do it? If you're told to open a file, surely you would agree that you need to fulfill two preconditions: that the path, the string, is not empty, it points to a legitimate thing, and that it is genuinely a file. It's not, for example, a directory or some other thing, isn't it? And the third is that obviously it's readable at all. If you're asked to read a file, you need to see whether it's readable at all. Now, these are cross-cutting concerns. This will be true irrespective of whether you're writing code for AI or whether you're writing traditional code, and so on and so forth. So it makes sense a little bit to make them into utilities. And obviously, I encourage you, without going into what I have put in my utilities, I would strongly encourage you to think about your library, your code, and ask, what are the cross-cutting concerns and what can you put into a utils library of your own? In my case, I check whether something that claims to be, that is supposed to be a directory, is really a directory or not, right? And so what is it? You check whether it exists, whether it is truly, if the path exists, it's not a file, for example, it's truly a directory. Is the directory readable? Is the directory writable? Because if you're asked to write output to a directory, you have to check whether you have permissions and whether you can write to that directory. Yeah. Check if the directory is empty, ensure that the directory exists, right? If it doesn't, create it, file exists, right? Likewise, delete a file is empty. These are basic utilities. So I wouldn't go more into it. I will then go into the config. You realize that in your case, like for example, in this bootcamp projects series, you will encounter, or you will need to create a lot of configuration files. I decided to use YAML, and I'll spend a couple of minutes talking about it. I don't know what is off here. Invalid child element in block. Okay, we are trying to create a schema for it. Something is off. We'll look into it. So the way, oh no, this is the schema, sorry. Where is my bootcamp config? Let's look here. This is it. So there are many ways that you can store your configuration file. You can store it in the ini format. You can store it in the JSON format. You can store it in the YAML format. All things considered, YAML, in some circles, YAML is as good as any other. Let's just say that which one it is gets to be a bit of a religious war, but they're just different stylistic ways of storing configuration. Do it in JSON, do it in ini, do it in the database, do it wherever you want, so long as it makes sense. So what are the configurations that we need in this project? Basic things, for example, what is my database? I took the simplest one for which I posted instructions in the course portal. This is the default port, username, passwords, a schema, documents. This is exactly per the tips that I had released. JDBC driver, no surprise. Then why do I need JDBC driver? Because if I do PySpark, Spark is essentially Java and Scala based, so it will need JDBC driver. What is the format of the JDBC connection? So it's JDBC specific within the database. Document directory, which directory are we going to use? So these are all no-brainers. Spark, PySpark will need Spark. Where did you install it? Models. Now, one of the most common things I notice, which is very endemic in English-speaking countries, it is a little hard for people to remember that the world has many more languages than English, and documents come in all sorts of languages. We all do that. Obviously, most of us don't have English as a native tongue. Nonetheless, when we write code, we sort of switch hats, and we almost always code exclusively to English. I would say this is a great opportunity for you to rethink that, not do that, right? Use always, as far as possible, use multilingual models, unless you're sure that you have to only work with English. In that case, take a language-specific model, English, French, German, whatever it is, because a language-specific model would be more accurate for data in that language, and of course, hopeless for other data. Whereas a multilingual language will work for about 180 languages, let's say, but may not be as good in any one language as a language-specific model. So those are the trade-offs that you have to make, right? Now, I noticed that even with basic things like sentence encoder, most of you are using the mini L6 and so forth, which is fine, but know its limitations. It works only with English. So long as your data corpus is only English and you acknowledge that fact that you can only function in English, is fine. Otherwise, if you are going to encounter data in multiple languages, then you should take a multilingual language. One hybrid approach that helps, but it's sort of a complication, is that if you have data predominantly in English and a very small percentage of data, let's say 5% data across other languages, then take a forked or hybrid approach. Sense the language of a document first, detect the language, and if it is English, use English embeddings, create a separate index only for English, and then create a separate index for all other languages using a multilingual encoder. And that approach will be actually highly successful if you do that. Right? Consider doing that, because then you have the best of performance for your dominant language, as well as you have support for other languages. And that's important. Right. Spacy is a library that we are going to use, and you'll see how and why I use it. Spacy is a pretty dominant natural language processing language. It has been written in C Python, is blazing fast. It runs quite respectively fast on non-GPU machines also. So consider that. Now,
yes.
CUDA.
Quick question. Do you plan to share this with all of us?
Oh, yes, of course. I'm going to release it all, but do not, but I will deliberately poke lots of holes in it so that you don't just copy it and say, oh, I'm done. In other words, I will make sure that your learning is not impaired. You still have to put an effort to integrate it into your system. Does that sound fair?
Absolutely. Thank you. That is.
Yeah. So that's that. Chunk size, I took 47. I noticed that the chunk size, why is there a limitation? Why do we need a configuration parameter called chunk size, guys? Anyone?
Because there is a limitation on the model can accept.
Excellent. Yes. If you use a BERT-based model, typically they'll have 512 tokens. Some of them have large 1,000 tokens. Some of the newer language models have 2,000 tokens and sometimes 8,000 tokens. And now if you go with one of the commercial models, you might be talking in 100,000 tokens, right? But remember, any commercial model is out of bounds for this course. If there is a lesson to learn in this bootcamp, it is that open source community is doing impressively well. It might not be doing as well as the commercial models and commercial houses, but if you want to see AI not completely monopolized and become the private beach estate of these rich guys, participate in the open source movement and contribute to it. Support it, use its models, and wherever possible, give back to the community. So a basic common sense, right? So Elasticsearch, no brainer. You put it somewhere, you create an index. All of you are familiar with Elasticsearch. Now, what are the services that I create? I'd like to talk about the services. right? So this service is, let me add some comments to that. This service is a plain vanilla, a fast API service, right? The reason I'm distinguishing it is a service does not do AI, does not need AI hardware resources. Now you may say, how is that possible? Would somebody like to volunteer and answer? How is it that in an AI app, the main doorway, the main microservice that receives information can run without AI resources? Anyone? Well, the only way it can do that is if it delegates all the AI work to other services, as helper services, isn't it? So it's the main service follows a delegation model. It's also called the chain delegates. So what you do is the main service's job is to route, to break up a job, break up a task into smaller parts, and decide which part needs AI, which doesn't. The parts that do need AI, then invoke another service that is actually mounted upon AI hardware. That way you save, because in real life, what will happen is this service may be doing, or typical things, fast API, etc. You may be writing a lot of React.js web front end, and there must be a lot of business logic and the standard enterprise application development, none of which needs AI hardware. But they do a lot of traffic. You can scale them elastically in a containerized orchestrated world very, very efficiently and cheaply, if without putting them on GPU hardware. GPU hardware is expensive. So it is worth doing that and making sure that on the GPUs you do only the work that is absolutely necessary. Otherwise, you don't do it. Right? So that is one consideration you must have. The world of microservices, typical microservices in business apps world, if you look at the profile of the activity, they are heavily IO bound. They're waiting for data from the database. They're waiting for data from Elasticsearch. They're waiting for this to happen, that to happen. And the CPU utilization actually is not that brutal. You don't put a 1,000 core or a 10 or 100,000 core or like a petaflop machine to serve your microservices. It's never done, right? It's done on modest hardware, very cheap, easily scaled out, elastic. On the other hand, the moment you talk about AI services, you're talking about very expensive hardware. GPUs are, they have one GPU these days costs practically as much as a house costs in America. You could, in the price of a GPU, you could easily go to some of the states of US and buy yourself an estate. So that should give you a sense of how expensive GPUs are, right? And they're getting only more expensive by the day. So you want to limit, you want to have very focused and tight services on the AI hardware. So what are the AI services that we put? We put these services. One is to clean and chunk the data, because cleaning is such a trivial thing. We just do basic concatenation, etc. But the main point is chunking. Before chunking, we prepend a tiny bit of cleaning of the data, because when you take data and you run it through, let's say Apache Tika, which most of you have standardized on, you'll realize that a PDF comes with a lot of empty lines. I don't know if you guys noticed that. And I don't know if you guys put some measures to clean it out, but it's a very good idea to do that, right? As much as possible, clean it out by cheap means. Like, for example, regular expressions work wonders. For non-AI transformations of text, regular expressions should be a go-to thing. You should be very conversant with it, guys. There's no reason why anybody doing AI should not know regex. There are books on regex. There are entire websites devoted to regex. There are regex helper guides. There are regex YouTube videos. And the regex is an old thing whose value has never diminished. We'll use some of that. But after that, we do chunking. As you'll see, we use a little bit of AI to do chunking, semantic chunking. Now, the semantic chunking we do is not too fancy. It is still, I would consider, in the class of simple AI ideas, but it is there. Elasticsearch, actually, I apologize. Elasticsearch is not a service, so I shouldn't put it here. I should put it in the family of non-vanilla services. Now, sentence vectorizer, as you know, we use a sentence BERT to do that, a sentence transformer to do that. Therefore, it's an AI service. We want to have a microservice that does nothing but that, and whose scaling, we scale it in such a way that we designate GPU nodes only for scaling those things, right? Those sentence vectorizers. Not only that, we might want to control the concurrency. You realize that unlike vanilla services, a transformer has only that much bandwidth for concurrency. You put too heavy traffic through a transformer, the whole thing, the GPU will fall on its face, however strong it is. Right? So you have to control the concurrency. You have to manage how much compute throughput you can accommodate and so forth. So for that reason, it's a fast search again, and fast index builder. These are the 4 AI services. So today I'll walk through specifically the AI chunk, AI services in the next hour, if that's okay. And if I'm going too slow, guys, let me know. Right. So the first, I suppose, is the chunk vectorizer. Here is how I do it. I hope it's let's go and do that. Oh, sorry, I went to the wrong directory, text. I have to go to text. Yeah. A text extractor. Okay, let's first go to text extractor, just to show you, which is the non-AI part, but as a warm-up, because you'll see the structure of the way I've put the code here. Once again, and obviously you can clean out these imports. We are using Ticker. We use Ticker for 3 things: text extraction, right? Detecting what type of file it is. Is it a PDF? Is it a Word doc? What it is? And the language. In which language has the text been written? I created a specific, again, exception dedicated for this text extraction process, nothing fancy. So here is the text extraction class. As you notice, the text extraction class is something that expects in its constructor the path, right? And this path, it will try to do a toString on to get the text first thing, and then a doc type, etc., etc. Now, when you notice what we do in the toString, what do we do to toString? It's a static method here, but in there, what we do is we check if the file exists. If it doesn't exist, we throw an exception, because you can't text extract from a non-existent file. If you find the text, and see, guys, I mentioned to you a simple rule. If you are doing I/O, if you are doing model inference, or you're doing a remote procedure call, RPC, in these 3 cases, definitely sing a song, which means do some logging, and wrap up all code that can potentially fail in try-catch, try-except blocks, right? Exception handling blocks, which is why you'll notice that, as I was walking through your teams, most of you have this line right? This you all have, but I put a little bit of ceremony. What are the ceremonies I put? This is what we people, like I was taught long ago, 20 years ago, we call it preconditions check, right? This literally almost in the first week of my working for a NASA project, I was told every function must have a preconditions check, which is what I'm doing. You can't you can't convert a file, extract text from a file unless you know that the file exists. Common sense. It should be more than that. I would encourage you to decorate it further with the fact that it must also be readable, not just exist, but be readable, right? So, or if not file readable, that too is important, isn't it? Right. So, or like this. So this gets a little bit better, right? Then you log it. You're going to parse this file. Then you go and parse the file. And obviously one message that I missed is I should say then that successfully parsed the file. And by the way, I say it as an info. I was debugging. In reality, there should be a debug message. In other words, you don't want to slow down your parsing when you're doing millions of files with the info level. At this moment, everything in the code sample is at info level so that you can see it happen as you run the code. Yeah. So the other thing is, this is a little bit more controversial. I tend to give type hinting. I tend to mention that if I create a variable result out of the parsing of the file, what in the world is that result? Right? And then, for example, and then from that, if I extract the content, I just say that it is str. This is called type hinting. Type hinting, guys, goes a long way in finding bugs in your code and in the IDE to help you write better code. Because if you type hint your code, then your IDE, whether it's Visual Studio Code or whether it is PyCharm or whatever it is, you're telling it that this is what it is. So later on when you use it, it will make sure that it can give you the appropriate hint. So it will warn you if you're doing the wrong thing. Right. Now, whenever you parse a file, there'll be a lot of trailing and beginning spaces, lots of empty spaces, empty lines. You can strip them off. That's it. Document type sensing, etc. So this part is easy. Text extraction. Now, as I was going from room to room, I noticed that obviously none of you have done it with this much ceremony. Most of you have just said parser from file. Now, it's a subjective matter whether you feel one way the virtue of just having this is its simplicity, right? The virtue of my style of doing it is that you'll have better clarity on what went wrong if things do go wrong, right? You can pick your style. Next comes the text chunker. Let's talk about the text chunker. What am I doing in the text chunker?
Asif, can I pause you?
Yeah, sure. Go ahead.
Yeah, if you do the type hinting,
yeah,
then you can use mono and compile your code into very high speed Python.
Yes.
It's compiled.
Very good. Yeah, that is amongst the great things. Yeah, you're talking about Mojo, isn't it?
Yes, Mojo.
Mojo. Yes. So yeah. So guys, obviously now this and Prakash, many thanks for bringing up this very interesting topic. As you know, people love Python, and one day and the next day they hate it. They love it because it's so easy to learn. They hate it because type hinting is missing, and it's just a nuisance to figure out what exactly does a thing produce. Right? Some people are annoyed by the indentation, but the one gross problem is performance. And it turns out that if you can actually, you can convert, in some sense, do a much further optimization or translation into high performance, low level code. If you type hint, there is an initiative called Mojo, which is trying to say, let us make Python into C, because we can bridge the gap if Python is type hinted. And it can run at the execution speed within ballpark of C language. If not completely there, then within the ballpark of that. Right. So that's that. A very good point. So I'll now talk about the sentence chunker. What does the chunk text do? Guys, again, one thing to mention, you notice that I tend to write object-oriented code. I am told that object-oriented code is now over, right? It's a failed philosophy. And so take it with a grain of salt. We all have our personal styles. Perhaps it's a bit too late for me to change my style. I tend to like object-oriented programming and functional programming. In fact, in the Java world, we used to do a lot of object functional programming, like use lambdas and MapReduce and so forth, filters, but do it in an object-oriented way. So some of that has sort of spilled over in my doing Python, and you may have your own style. Right. So this is a class. It uses a mixin configuration. Do you notice that there's a mixin? Why in the world would I use a mixin? So a little bit about mixins, if you don't know what mixins are. Mixins are interesting things. They are reusable functionality, and they generally tend to follow a concept or a word that I use, or maybe I haven't seen that used that often. It is a single responsibility pattern. A good mixin is something that does only one thing, and many, many people need it, right? So, for example, in this project, you would agree that reading the YAML configuration file and getting something out of it is a functionality that many pieces of code, it's a cross-cutting concern. And something wants to read from the configuration, they shouldn't have to reinvent the wheel. They should instead delegate it to a configuration. So therefore, configuration class becomes a great candidate in my mind to be a mixin. Right. And again, none of these are hard and fast rules. You may differ. And I would like to hear about that. So, but I've created a mixin. It has a method called load configuration. What does it return? And now a little bit about this. When you use YAML, many of you use PyYAML. PyYAML has a couple of defects, which is that it completely erases your comments in the YAML file. So if you look at a YAML file, which was somewhere here, not this one, configuration py. Where did the YAML file go? Boot config YAML. Yeah, you notice that we put a lot of comments to make it more readable or sensible. All of those comments, if you read from a PyYAML and then you use PyYAML to modify the configuration and write back, all of these will disappear. But so somebody has split the library or forked that library and created another library called RUML, which honors and protects your comments. It keeps them. That's why it creates a commented map. Yeah, just for you to know. And it also, by and large, preserves the order of your entries. So this is it. I read the config file. Once again, the moment you have a config file, my way of thinking is preconditions, post-conditions. What are the preconditions? First of all, reading a config file is IO. The moment it is IO, therefore, I will do both logging and exception handling, right? So you will see a lot of log statements and you will see the whole thing. Opening of the file, the inner core of it is just 2 lines. But you notice that there is a lot of ceremony that I've wrapped it up with. Yeah. And so I'll just walk a little bit through it. Config file is none, then complain. Just say, hey, you forgot to specify a config file, right? But this is called configuration by default. You don't have to specify the config file if you're fine with the default one. And the default one that we have kept is obviously the Bootcamp YAML, right? Bootcamp YAML file, right? Now, when you write a YAML file, this is a question some of you raised, I believe, I think Satyam raised, that he's worried that how do you validate that all the necessary properties or entries or configurations are actually present in the YAML file? There are multiple ways of doing it. One way, for example, is to use Pydantic class and then validate it. Data validation of the bean, make it a required field. It's a good way. My thing is that it tends to, you lose comments, and I tend to emphasize readability of code quite a bit. So I had to forego that. Instead, I took the different approach. You can validate the YAML file against a schema. You can create a schema, which is what I've done here, but it seems to have a bug at this moment. But once you create a schema declaring what must be there in your file, then in your config file, at this moment, I've commented it out because obviously there's a bug there. You can make sure that the YAML file that you read and the configurations that you read from it do adhere to the schema. In other words, it has all the necessary fields that you want it to have, right? So this is an alternative mean. I prefer this mean simply because of the overwhelming importance I put to commented code, right? So here we go. You can read this. If the file doesn't exist at all, if neither the default file exists nor a specified file exists, we of course throw an error. We raise an exception. Otherwise, you say that, all right, I found the file. Again, log it, sing a song. Check for the schema validation file. If the schema validation file exists, if not exists, again, blah, blah, blah. And then go read the file. This is the part that almost all of you have done, right? To that.
Asif, can you go to line number 62?
Line number 62. Yeah, it's deliberately commented it out as false so that it doesn't run, because at this moment
62.
I am at 62.
Okay. Yeah, if false.
Yeah, it's deliberate because at this moment in my schema definition, there seems to be a bit of an issue. There's something not quite right here. Most likely an indentation or something is off. right? I'll figure that out. Or how about this? Better still, you guys figure that out. And then mark it, then remove the if false. Yeah. This part looks standard, guys, I hope. The one thing that I would say is, so in contrast to that, if you had done something like this, like f is equal to open like this, 44 is what I would call anti-pattern. Don't do this. Why should we not do 44? Why should we do this long? See, this is the opposite of everything that I've done. Isn't it, guys? Why should I not just use this? Because I saw it in some of the solutions. Anybody would like to chime in? What's wrong with this?
We don't know what happened with the open.
Exactly. That file handle is a dangling file handle, number one. Number two, we don't know whether the file has been, file even exists. We don't know whether the file is valid, right? And so you will just get a nasty stack trace if the file doesn't exist. And even if you have successfully read it, you're basically at the mercy of the operating system to go clean up the file handle after you. So while this is great for code snippets on the web, but it's not great for production grade code. Try not to do that. Right? And see, here's the thing, a valid criticism is doing it like that. It creates verbosity in code. And is it necessary? You guys have to reflect on your own what you think about that. But it is my style. Next, let's go to the simplest of them. Oh, should we first go to sentence encoder? No, let's go to the text chunker. So now we went to the text chunk. Will the text chunker need to read the configuration file? Yes, because why should it need to? Oh, look at this. We are picking up some AI models. Do you notice that these things, all of these models and parameters are being read from the config file? Generally, you can tell a lot about what somebody has done in code by simply reading the imports. From the imports, you can say spacey, sentence transformer, both of this. And then there's a configuration mix-in. Just reading the imports, you can conclude many things. You can conclude we'll be doing some linguistic processing. We'll be doing some sentence embedding, and we'll be reading something from the configuration file. So never overlook study of the imports whenever you're reading somebody's code, right? And then go straight to the init and you would know pretty much the lay of the land. By now, I would argue that if you know what you're looking for, just this much is more than enough if you're a good Sherlock Holmes, and you may not even need to read the rest of my code. But for what it is worth, here it is. Given two vectors, alpha and beta, does anybody notice something very funny about the A and B there? Arguments, 38.
Yeah, it's a Greek.
Yeah. So one of the things that I delight about Python and Julia is that Greek letters are a first-class citizen, and mathematicians love Greek. That's why whenever mathematicians talk, people are saying, it's all Greek to me. I'm joking. Anyway, so this is the cosine. As all of you know, it's the dot product normalized. Right? Create chunks. So given a text, how do you break it up into chunks? Once again, the way we do that is, and by the way, why am I putting all of these comments in here? Because it will, as you will see, they become part of the read the docs. In a second, I'll show that to you. This is your spacey being used. What it does is it takes your text and creates a nice linguistic model out of it. That model will tell you what the sentences are, what the tokens are, what the nouns are, what the verbs are, what everything is, what the punctuations are, and it will do it in a language independent manner. Right? So if you think that full stop is the boundary of sentences, you're mistaken. Look at, for example, Hindi, Sanskrit, anything. Full stops are nowhere to be found at the boundary of a sentence. Right? And so forth in different languages. Clean text, what do I do? Now, this is the use of regular expression. Whenever you find this sort of a thing, pattern, this what I'm saying is that if you find more than one space, replace it with a single space. If you find a lot of new line characters, replace it. But when do you do that? See, the trouble is, if you get rid of the new line characters, it can be bad. Why? New line characters are good indicators of paragraph boundaries, isn't it? So why am I doing it, guys? Can somebody tell? Why am I removing the new line characters? Why am I removing carriage returns like
Because
this?
fundamentally you're using the spacey sentence the logic in there to be able to parse out the or make the paragraphs later on. As a result, you kind of don't need this new line characters anymore.
Yes, Manish, you're almost completely there. See, the trick is, notice that I'm inside a sentence. I'm not talking about the whole text. When I'm just iterating over sentences, when I'm looking at one sentence, do you really appreciate that how after 4 words of a sentence, there are 2 blank lines followed by the rest of the sentence?
Makes sense. Yeah. Okay.
You don't want that. So you would rather that your whole sentence is one long line, which is what this does, right? Makes your sentences into single lines. It's just a very basic cleaning. And then also, if append the text and clean the text and append it only if the final length of the clean text is greater than 0. In other words, there is still something still remaining. Your entire paragraph may be made out of blank lines and spaces or tabs. Then no point in appending it to clean text. Then comes the question, how do you chunk it? You need to do the 2 things. First is the obvious one. You break it, you encode that sentence and you see what is its cosine similarity to the previous sentence. This is the most basic one you do. A better one, perhaps I could say, which I suggested to some of you, is to do mean pooling, but I didn't do that because the code began to look a bit more complex. So I thought, let me not confuse people. So here it is just comparing it to the previous sentence. When you compare it to the previous sentence, actually it becomes quite imperfect, but code looks simpler. The point that I'm making is do something interesting to find that out. It's not as easy as you think, though I would encourage you to use something a little bit more sophisticated than just cosine similarity to the previous sentence. But when you do that, if the similarity is greater than a similarity threshold, take it. Now, what you'll realize is that sentence similarity threshold is very context dependent. If you're looking at a scientific domain or specific literature about a topic, you will see that you would want to set the threshold as like, close to 0.7, which is the cosine of 45 degrees. If on the other hand, you're looking at general purpose New York Times articles, you will realize that it's something interesting. I was looking at one author's style and I found that every sentence differed from every other sentence. Most of the text was self-contained, and for effect, for contrast, for whatever, that author's style was that its semantic content would be different from the previous sentence. So what do you do then? Then you set the threshold very low. Right? Even setting the threshold to 0 is okay because, 1 second guys, because thresholds can go all the way negative. 2 sentences, are wildly different if their similarity is negative. So remember the cosine of a theta goes from -1 to +1. So even 0 is reasonable, though I never find 0 quite useful. I set it to at least 0.1, 0.2. Even for general newspaper text or, opinion text in New York Times or something like that. Yes, somebody had a question.
Yeah, I think this is like, deeply subjective. Are there examples that you can show us that, we can also relate to? Because we're comparing like somebody's subjective opinion to numbers. So there's qualitative and quantitative. Is there something that, since it sounds like you've done the research, is there something that we can look at? Because
Sure. I would like to share. I can share my Jupyter Notebook findings. It was very interesting, actually. Certain domains where things are very tightly argued and well argued, you will notice that the sentences, they have a lot of cohesion. they are proximal and very similar to each other. Whereas I noticed that political opinion statements, they go more for effect. And I'll show you my Jupyter notebooks. I've analyzed text from many domains, going all the way to history and anthropology and so forth, and politics and so forth. So for whatever it is, and so therefore I consider such thresholds more a hyperparameter of your model, to be decided judiciously based on what people perceive as semantic separation.
And it also depends on the corpus, right, Asif sir?
Yes, very much. Corpus is, that's what I said, the domain, the corpus.
As well, yeah. And like Shalini was saying, this is, I think, subjective, because I had a similar experience. I was comparing exactly the same thing, a Bloomberg article between two passages, and the net effect was that some of the, like, where there was a natural paragraph boundary according to the author was not necessarily what this algorithm would have you believe. Like, it would say, oh, this is the next sentence, or this is the,
Yes.
there were
But
some
that
false
is
alarms,
true.
so to speak, as well.
Yes, that is very true. So Shana, there, first of all, your findings are very correct, though with one caveat. A paragraph boundaries sometimes are arbitrary. Sometimes editors will say, hey, your paragraph is too long, can I break it here? Right. So to that extent, a good semantic chunking should outperform such editorialization. So there it could make sense, but you're absolutely right. See, it's a very primitive measure and therefore not the best. But for whatever it is worth, it's a hyperparameter of your model, and you can sort of improve upon it with all its caveats and limitations. Right?
Asif, I have one question associated with this.
No, guys,
Go ahead,
one second. I have Prakash raising his hands for quite some time. Prakash, go ahead.
Yeah, Asif, sorry. This feedback is okay. So Asif, question is on the text which you have splitted in the top by, let's say, 400 characters or 500 characters, and then each sentence you are trying to identify its similarity.
Yeah.
And then in the next line number 71, if they are similar, you are adding it again on 71.
Yes, what I'm doing logically.
And
now see, I'm trying to make chunks. So think of chunks as bucket. Okay, here's the thing. Imagine that you're filling these sentences are boxes, right? Or clothes, something. Imagine that you have 5 boxes for packing. You need to fill the first box or the first chunk. What will you do? You'll put a sentence. Then you need to decide that you put a cloth there, your pant there. Then you want to bring in another sentence. Let's say that second piece of cloth happens to be not a cloth, but it happens to be a kitchen utensil. You're packing. You certainly don't want to put it in that box. You want to start a new box for it, isn't it? That is why you check the similarity. But you also know that even if you get very similar things, like you keep on getting clothes and you keep on putting in the box, you can only fill the box so much, after which it will be full. So there are 2 conditions that you need to check. One is if the tokens that you will add will cause the box to overflow. And if it doesn't overflow, there is still a second condition to make sure that what you are putting in there is similar to what is already in there. Like you're not mixing kitchen utensils along with your clothes.
got it. But question is, even though after that entire text you are doing vectorization of entire text.
No,
so
of
even
the chunk of the chunk. So what happens is this method doesn't do vectorization at all. This service just returns chunks. Given a text, it will break it up and return chunks.
I see.
That is it. Right.
Asif,
Yeah, go ahead, please.
Asif, I have a question. So here we are making sure that each chunk has a good context. It doesn't have noise. It doesn't bring in another context. We are discretizing the context, right? And how does that help when we load it into the model? Meaning, how does that help in semantic search on the whole?
See, Jay, that's the main point, right? Ultimately, when a chunk of text, a piece of text, becomes a point in a vector space, you want it to be a semantic embedding. Means if it is about atoms and orbital structure of atoms, it should be in other subatomic physics statements. But if you look at, for example, I'll illustrate that to you, why we should do this. Suppose let's go to Wikipedia.
Because there were some techniques that involved chunk overlap as well. And
that is true.
Yeah, when there is overlap, and that helps. And when there is this kind of discretizing the context, and that also helps. That is where I'm trying to, I'm confusing a bit.
Let's say that we search for something. What would you guys like to search for? Let's say transformers. Right. Well, it turns out that Wikipedia doesn't quite work with the AI at this moment. Transformer. Let's just say transformer machine learning model. Look at this. This is about the transformer, what it is, what its history is, etc., etc. A transformer is a deep learning model and was proposed, blah, blah, blah. It is notably required, blah. Then the second paragraph gets to its use. But then right after that, it gets to the history of it, isn't it? And so predecessors, etc. So if you take the entire text of this article and you make it, imagine that it becomes a vector. As a semantic vector, what happens? It becomes a mix of the semantic vector for this, the semantic vector for this history, and the semantic vector for this. And in a way, its overall value is diluted, isn't it? Because now you don't know what it is about. There's too long a text. You're lost in the land of text. There are too much semantics in there. Whereas the idea was that given a piece of text, there should be just one semantic concept in it. You realize that I very provocatively called the title of this chapter of this project, The Metropolis of Meanings, isn't it? One vector should represent one meaning or one context or one semantic. But if you look at this article, so much is said here. And that is the value of chunking. The real reason for chunking is not so much that transformers take only 512 tokens or they take only blah, blah, blah tokens. Even if let's say that you use cloud and 100,000 tokens are fine. But when you're doing search indexing, it is still a good idea to chunk because you want to focus each piece of text to one meaning, one idea, not many ideas in the text. Right? That's the point.
So paragraph 1, let's say it talks about, like we are reading, let's say a famous cricketer, Sachin Tendulkar's Wikipedia. And the paragraph 2 actually talks about some other person, right? Like say Kapil Dev. So in a semantic search, like when paragraph 1 is different, paragraph 2 talks about something else. How does it help?
It helps because if you break it up into chunks like that, then when you're looking for Kapil Dev or a spin, whatever, he was supposed to be a great spinner in bowling or something, right? I don't know what it was, but let's presume for a moment that that was his forte. So then you're searching for that. It would show up in the search results. And my apologies to cricketers who are disgusted with my ignorance. But and suppose you're looking for Sachin Tendulkar's amazing style. You get that. What you don't want is you search for something and this particular article, which is very relevant to Kapil Dev, it doesn't show up because it also shows up low in the search results because it also contains talk about other cricketers, right? Which dilutes the vector, moves it away from where it should be.
I see.
Yeah, that's the point.
Thanks, Asif.
So that's that, guys. That's the real reason why it's a good idea to chunk, especially do semantic chunking. So I wouldn't say more about it. You can optimize NLP loaders, like whenever you create a model, you can decide what things you're going to do, what you're not going to do. Like in this case, we don't do token to vector named entity recognition. Now this gets a little bit into what I would call linguistic structure, those of you who are aware of it. And obviously those of you who took my the Spacey course last year, an NLP course, know what I'm talking about, but for the rest, I'll just skip it for now. But if you remember, I mentioned the optimization, that from Spacey load only that which is necessary. In fact, I myself had forgotten, and it's my pleasure actually to see that one person, one of you guys, did it right and remembered it. Yeah. And I noticed that and I said, aha, yeah, yes, good that you did that. So this is it. This is chunking. So now I'll take as chunker as a thing. It's a code. It's a bit of code that will break up text at the end of the day and return a list of chunks of the text, right? Based on certain parameters. Now the thing is, who should do it? Where should it happen? It is certainly using AI models. It should be on a GPU-driven thing. So for this, you don't want to just use Fast API or things like that. There are structures that have been built on top of Fast API, but which are much more designed or infrastructure to serve AI models. So model serving is a whole cottage industry of open source and closed source projects. There are many such things. And depends upon what trade-offs you need. For example, a PyTorch serve will only serve PyTorch models. TensorServe will only serve TensorFlow models, right? Or Triton will only work on NVIDIA cards, but can give you a lot of performance and speed and optimization, right? And so there are many, many model serving frameworks that serve the model at runtime. I would strongly encourage you to get introduced to one of them and use that. One of the relatively easier model serving technologies to use is RayServe. A Kubeflow is another because it containerizes it. If you're within the Docker and the sort of Kubernetes world, Kubeflow is a great choice. MLflow is there, especially if you're very close to Databricks technologies and so forth. So there are many such things. For the sake of this bootcamp and for educational value, I took RayServe because its learning curve, as you will see, is close to zero. In fact, I claim that in 5 minutes now, I'm going to introduce you enough to RayServe that you'll be able to use it immediately. Right, so let's go and look at the service part of it. How do you serve this? So this was chunker, right? Let's go and clean chunk service. Right. See, one of the things I do, you'll notice is that in my so-called infrastructure code, like, microservices, that, I never put heavy duty logic. I always delegate heavy duty logic to delegate actual functionality, core code, right? Here, the core class was chunk text. So here we go. Let's look at this class called clean chunk model. It uses the chunk text. When it gets a request, it will extract the JSON. From the JSON, it will get the text. It will call the chunker to chunk the text, and it will return the chunks. Does it look dead obvious, guys? Assuming that the chunk text class does its job, this class does its job, which you just saw did it respectively well. Would you agree that this code is dead simple? Now, once again, when you are receiving a request, remember, does it follow into one of those categories? IO, RPC, and model inference. Does it come under any one of those three categories? Anyone, guys?
IO?
Yes, it is IO. It is at the receiving end of a RPC. And guess what? You are calling AI service along with it, right? It literally has that. So a good idea, wrapped it up with log, right? A better thing would be if I had wrapped it up as a further improvement, if I should have wrapped it up in a try except block also. Right. So something to remember, but for simplicity, I left it like that just to show that when you write your core classes, don't write it in your REST code. I've sort of been moving from room to room and seeing that the microservice code or the actual service code that you write is too heavy with actual logic. Don't put logic there. This sort of code takes time to debug. You want to, where things are unclear, things are coming over the network, there will be network latency, ports may be wrong, client may be calling the wrong server, God knows what may be happening. Keep this code dead simple. You will be doing your ML ops and your DevOps guys and your system operations guys a big favor. And because they will know where it failed, they won't have to muck through your very complicated AI code to figure out what happened. They just need to know that it failed at line 45. If it failed at line 45, it was not a network failure. They are happy. It was not a server being the wrong server being called, whatever it is. They know specifically that you, the dude who wrote the AI code, were at screwed up, and so he can just pick up the phone or send you a Slack message or email that, oh gosh, you need to fix this, or file a Jira ticket, whatever. So it makes separation of responsibilities much easier if your code is clearer, like separated out like this. So please do that. So now comes the part, what exactly is this RayServe? What you do is, I'll give you an idea of how it comes. You can install RayServe. It is a simple pip install. So how would you do that? If you guys are seeing my console at the bottom, are you guys able to see my console at the bottom? You do pip install RayServe. That's all. One simple pip install will do the job. I'll do it again, even though it's sitting on my machine. It's done. How do you start a Ray server? I'll start it and show you. Ray, I'll first stop whatever I have. Force. There you go. So Ray has stopped. Well, observe something. It had 42 Ray processes. What in the world are 42 processes doing? This is where it does. It does a lot of parallelization, distributed computing, scale out, scale in, and so forth. It does all the heavy lifting for you. So I'll start the Ray again. You notice that Ray has started. It is inviting you to monitor it in a dashboard. We'll go to this dashboard, see what in the world is going on here. Here we go. Oh, look at this. It has come up. It's in a healthy state. There are no jobs waiting. What are the jobs? Nothing. What is it serving? Nothing. Yeah, at this moment, nothing is. Oh, in the past, it has been serving quite a few things, maybe, but now it is at this moment empty. Metrics. Well, we haven't integrated many things. It's a basic one. So now let's go to the code and say just a couple of lines, very basic lines. You're going to say this code, this service that you wrote, the way you think of it is that you write a code, a REST endpoint code, let's say. Then you ask a Ray cluster. You reach out to a Ray cluster and you say, hey, you know what? Why don't you manage my service for me? Are you understanding the language? You're saying, hey, you are this Ray cluster. I'm giving you my code, bind to it, and take my entry point, bind to it, and then expose it at a certain port. And this is the route path /chunker. So you will go to localhost /chunker and so on and so forth. But you do the scaling. So in other words, if you want, run it on 50 different machines, but you do the traffic routing from client to this, so that as far as the client is concerned, what they see is just one URL, right? You do internal traffic dispatches, you do internal scale in, scale out, you do everything basically. Right? You want to do things like that. You want to use a model serving framework. You don't want to home grow these things. Are we together? And to do so is very easy. Here you're saying, okay, I want to connect to a Ray cluster that's running locally. What do I want to do? I'm going to expose an entry point coming from this class, like this class. Where is this class coming? There is a decorator. And now I'll show you the part that I put on top of the class. I decorated it with a serve deploy. When you look at the serve deploy, I have put certain parameters here. One of them is Ray actor option. Number of GPUs. How many GPUs do I have on my machine? Well, I happen to have 1. 0 is perfectly fine, right? Number of instances to deploy it on. So I'm saying, okay, you can have, for this particular microservice, you can have up to 2 instances, like 2 different processes running it. And you can do the auto scaling. Minimum replica 0. When nobody is using it, scale it down to 0. When somebody is using it, well, scale it up to a max of 2. And then comes a factor that sort of is important. Think through it. How many concurrent requests can you do? And for that, you have to ask yourself, your GPU, what is your max batch size that it can take, right? Or what is the max number of computations it can run in concurrently? Usually it is not millions, it's very small number. Even on a 4090, even for something which is just text chunking, 100 is really pushing it, right? You should have, for typical hardware, it is good to do this. See, if your chunking takes, let's say, just 30 milliseconds, you realize that if you do 10 things, it effectively you're doing close to 300 requests per second, which is a very, very high throughput number, right? So the max concurrency, don't go aspirational or too ambitious about it, right? This is enough, actually. Yeah, 100 is a bit of an overkill for something like this. Right? So you have a chunker. This is it. So guys, does it all make sense? Async is always a good idea, async await, to do it asynchronously. But if you don't do it, well, then you have a synchronous call, no big deal. Guys, am I making sense?
Question is this Ray.
Go ahead. Ray
is equals to Ray colon localhost port number. So it is trying to distribute this service on multiple machines, and everybody will have a running port on localhost 10,00001.
Yeah.
Or how
so
does
what
it
happens is that the cluster has a exposure. Cluster is saying, I'm available and listening at this machine. If you want to submit a job, submit it to me. It will go submit it to you.
I see.
Right? And it will spread out the job everywhere, and it will take care of the dispatch.
I see. Got it.
Yeah. It's a pretty powerful feature, isn't it?
Asif, so architecturally, how is this array kind of working in this picture? So it's sitting on top of the cluster where all the chunking processes are taking place?
Yes. No, Ray is the cluster into which your chunking processes, chunking and things can be deployed. And what you would do typically is you would deploy Ray on GPU-enabled systems. Right?
I see. And Asif, adding to that previous question, this service will be called through the PySpark cluster, right?
Yeah, you can call this. In fact, I'll show you an example how you can call it through the PySpark cluster.
Okay. So then parallelism makes sense in this setup.
Yeah, it does. See, what is happening is, so I will make a little bit of an editorial comment, and people, especially you, Prakash, you come from cloud era, big data world. I want to hear your perspective. Here is what I find. Over the years, when big data...
I hear a lot of echo. Sorry to interrupt.
Yeah, guys, Prakash, maybe you should mute yourself for a moment. Yeah. Oh, guys, please mute yourself. We're getting a lot of echoes.
It's gone now. Thanks.
Okay. So see, big data movement that started with the famous paper MapReduce. The fundamental call and big statements in the architectural community saying disk is the new tape. Yeah. Hard disks have become extraordinarily small. Let's not take data to the compute by running SQL queries. Let's take compute to the data, right? The whole NoSQL movement came about. You would take computations, make it as local as possible to decrease network overutilization or clogging bottlenecks. All of those made a lot of sense in the early 2000s. The world has changed since then. If you look at today with the AI world, some of the things that comes about is some things are not parallelizable, massively parallelizable. Except for big companies, you and I, like normal Joes, we don't have access to 10,000 GPUs, right? And so it is not that easy for us to spread a computation such that 10,000 GPUs can, in a distributed way, go fit into that. Other thing, hardware-wise, network has become insanely fast these days. 100 gigabit networks and 400 gigabit networks in the data centers are very common now, right? 400 gigabit is the norm almost. Even in support vectors with our pretty much shoestring budget, This entire building is wired with a 40 gigabit wiring, but 10 gigabit switch, because we can't afford 40 gigabit switch. So networking has become way, way faster than it used to be. People have moved away from mechanical hard disks to SSDs. Nobody would have thought in his right mind to run big data clusters on SSDs. But now more and more you are seeing such deployments. And so data itself, memory has become so cheap that a lot of these data centers, I mean, people have created layers on top of data storage, caching layers, right? Near data they create. So the world architecture world has changed in quite a bit. And obviously some of the topics in big data have to be revisited, especially with the growth of AI workloads. So I have used PySpark, but I must say I have used it with some concerns, with some reservations, because think about it this way. Look at this chunker. If I have one GPU, on one GPU, if I run a parallel, I have actually the chunking job, the pipeline, the text extraction from thousands of documents becomes after the text extraction, it becomes a chunker. I'll show you the extractor. It runs just fine. After that, it goes to the chunker. But what will the chunker do? You can run it in PySpark. You can run a massively distributed parallel computation, but there is a choke point. The choke point is the number of GPUs you have. And so the size of the ray cluster will never be like 100 nodes. Usually not for normal Joes like you and me, right? And so it is a thing to think. And I think Databricks has been trying to make some dent at it of what does it do in view of, and they try to literally create their own GPU cloud, as you know, for Databricks, hybridizing Spark with a big AI workloads. Unfortunately, it's all very proprietary solution. It's not in the open source. But what is in the open source is the plain Spark, on which is the PySpark layer. And so is it the right way to do things? It is not a bad way of doing things, but is it absolutely the right way? I don't think anymore. I used to think, but I don't think so anymore. All right. But what are your choices? At the end of the day, it boils down to what are your choices? And so I'd like to hear what you guys find. I would really love to learn from you guys. If you guys have other findings, other considerations to talk about, let's collectively find out, in view of modern realities, how do you hybridize as a massively distributed computing world when it makes calls into another world, AI world, where resources are at a premium and rationed? How do the two come together, and what is the best architecture? One is the one that I've written. I am not saying by any means this is the best, but what is the best? Let's find out.
I mean, nowadays the GPU is the most scariest resource available.
Yes,
so
that's
from
right.
previously the disk drive network, and now it turned out to be a GPUs.
Yes. I mean, I'll give you a perspective, guys. In the cost of one GPU, one H100, you can buy how many CPUs? Make a guess, somebody randomly. 10 CPUs? 20 CPUs? You'll be surprised.
Know the actual price.
You can actually buy 250,000 CPUs. In the cost of one GPU, you can buy 250,000 CPUs. The cost difference is that extreme. It is ridiculous almost. Am I right? No. I must have gotten my zeros wrong. Maybe 250 GPUs, sorry, CPUs. One GPU costs $80,000. $1,000 gets you easily 5 CPUs these days. So 80 times 5, 400. Yeah, 400 CPUs. I exaggerated 250,000, 400 CPUs. So the price difference is 1:400. Right? It is just unbelievably large price difference. And we need to, and again, at the end of the day, software architectures are driven by hardware considerations. We need to be mindful of that. Think about it. Anyway, so guys, did you get a sense of this? If you see my chunker, you can understand the sentence embedder encoder, which will be even simpler. Again, sentence encoder needs to know the configuration file. Why? Because it needs to know which models to load, whether to normalize embeddings, to do what, whether to go on GPU or not, and so on and so forth. But the actual embedding is very easy. You just encode. By now, all of you are familiar with this. Now, whether to normalize the embeddings or not to normalize the embeddings, it is a question that keeps
Asif, before
coming.
you move on,
Yeah.
one quick question. Can you repeat a little bit about models of framework and when to use this models of frameworks?
If you have AI models that you're serving, you should always use them. The
But
only
then
question is which one.
You need to have a clean boundary, right? You have,
Yes.
in this case, since we are getting JSON as an input, yes, fine. I can use the model for chunking and get a response and pass it to the next service. But if I had to call another like third-party service to do my model processing, then Ray might not be a good option, right? Because you said I haven't looked into Ray, so I might be wrong here. What I heard from you is Ray's based on clusters, and these clusters are capable of scaling, but they won't scale the DB or something that you're connecting with.
Yes, yes. So what has happened is that the world is fragmented into little corners, each with its own optimization. For the AI world, you need to use some model serve framework. Raise there, all of these are there. Tensor, PyTorch serve, TensorFlow serve, and so on and so forth. Kubeflow, MLflow, many such frameworks. At the end of the day, pick one, but the general consensus is pick. Don't just go with fast API, because then you'll have to essentially reinvent the wheel. You'll have to do your scaling through Dockers. You'll have to do management of traffic. You'll have to basically bring in the Kubernetes, etc. Which is why Kubeflow, by the way, is a simple alternative, because that's exactly what Kubernetes does. So if you leverage Kubernetes, if you are on Kubeflow, it is a very thin layer of AI on top of Kubernetes cluster, with the constraint that the cluster only runs on GPU-enabled machine. That's an alternative to it. But go with a model serving framework. There's a lot that happens here. Don't just write your own fast API. That's a lesson to learn.
Asif, what about Dask?
Dask is great. See, Dask is an amazing framework that is at the intersection at this moment of data science and data science at scale. So first of all, I must say that Dask is something I periodically get excited about and then forget about it. I haven't seen too many people running transformers on Dask. And since we are LLM-centric course, maybe we should explore it. I don't know what the latest state of the art in Dask is, what those folks are up to. Maybe they have started serving LLM models and transformers very efficiently. But the last I looked at it, it wasn't like that. But so check it out. Go ahead, please.
Is Ray a single node cluster?
No, not at all. Ray is a cluster manager that manages traffic across many many servers. So guys, play with it. Now, see, I'll tell you the strengths and weakness of Ray. Ray doesn't do any model optimization at all. It says, bring your own optimization. For example, if you use TensorRT or Triton, those guys, they will take your code and they will optimize it for the NVIDIA hardware, because they are released by NVIDIA. Now, what happens is that when you write code, these run on their hardware. They have to be transpiled into machine code. A lot of the things in NVIDIA are completely secretive. They have never really released the internals of their architecture. So open source community is never able to really optimize things that run on NVIDIA to the same extent that NVIDIA drivers do. They release CUDA, they release their stuff. But even then, taking something that comes from NVIDIA will certainly work absolutely wonders on NVIDIA. Will it do the same thing on your neural engines of Apple? Probably not. Will it do the same level of performance on AMD's upcoming, what is it called? ROCm chips? Probably not. In fact, not. The simple answer is not. Right. So the world is fragmented at this moment. Ray's one benefit is that it gives up some optimizations, but is the Switzerland. Like it's portable. You can run it on anything. You can run it on your laptop. You can run it on a server. You can run it on Windows with some caveats. I noticed a couple of you running Windows were having, let us say, very entertaining experiences with it. Then it can run I mean, let us say that it runs on all genuine operating systems. Right, very well. It doesn't give you any particular optimization. And it is a legitimate piece of software. It's not written by bozos. It's written by some really, really smart people sitting at UC Berkeley. The same lab that produced Spark, the AMP lab have gotten renamed to something else. I forget what. But it is the product of the same lab that came out with the Spark project. What's that? Rice Lab.
Rice Lab.
Okay, yeah. It's the product of the Rice Lab. Have they all become rice eaters? No, I'm kidding. So after the biryani, it's hard not to make the joke. All right, guys. So there you go. Ray, see, guys, get introduced to Ray because this learning curve is 0. And I sort of wanted you guys to do your project, the first project, your own way, so that you struggle. And after the struggle, you learn the value of AI-specific serving systems. Right? These technologies. Pick Ray for its simplicity, then graduate to something that is your hardware specific, that works better on your hardware. Right?
So
does that look like a fair bargain?
On top of Ray also, the way you do that is you remove the scheduler and then use the underneath Ray scheduler. But most of the ML framework comes from Dust, so that's also possible.
Oh, okay.
So there's a Dust on top of it.
Ah.
So the Dask scheduler is not fault tolerant versus the Rays one is made better because they are the Spark guys, right? So it's something like bringing Spark to Python world. So that is what
exactly
is great.
Yes.
And then getting the data frames across is the Dask framework.
Yes. Yeah, and you brought up a very good point, guys. Ray's one great strength is this amazing scheduler, a very mature scheduler. Right? If you ever look at these guys who created Ray, they pretty much lead their conversation by talking about their scheduler in those presentations, of how great it is. Thanks, Sachin, for sharing that. So guys, you notice that once you see one piece of my code, the others all begin to look the same, right? This is your sentence encoder. This is your index searcher. What do you do in the index searching? Do you see how simple my code is? The init will be obviously reading the configs, but the actual do part will be index.search. That's it. Right? This is already implemented more or less correctly. The only thing missing here is that try catch. Why did I say that there is something still to be done? We forgot to log and do the usual ceremony, logging and singing and try catches.
What is the device in that?
CPU versus GPU.
I see.
Right. Likewise, the fast indexer. What do you do? Indexing is a little bit more complicated because you may have more complications, which particular indexing algorithm you do. Oh yeah, indexing has a little bit of a caveat. See, when you create an index, there are many sort of indexing. When you create a fast ANN search system or file, there are different indexes you can use that use different geometrical or data quantization approaches. The flat L2 is the easiest because it's brute force. It just looks at Euclidean sort of a distance. It is also the one that defeats the whole purpose of using ANN, right? Why would you do that then, right? It is good to do prototype to start with, but gradually as you become that, you use something else. Now, the second thing that I would say is HNSW, on the other hand, is graphical. It is computer heavy. Some people found that it was way too heavy, and IVF, inverted this thing, file index, gave almost the same accuracy or performance. And some people felt that no, it doesn't. So your corpus, based on your corpus, you have to choose. One thing that people worry about, almost all of you worried about, is Fairs will just tell you how many rows have been indexed so far. So you guys were taking that and storing that in your database. You don't need to do that. You can wrap it with something. See, the first thing is that this is the property of indices. These have been very carefully thought through. All of these approximate nearest neighbor people are people mathematically trained, and mathematicians love commutativity and additivity, right? The whole things that keep talking about associative algebra and things like that. So in other words, an index is useful only if you can create many sub-indexes in parallel and then merge them together. Indices make sense only if, for example, I give you an ID and you respect that ID rather than just taking it in and then giving me a number of items I've stored that you have to use as an ID. So remember, what you need, look around. Will millions of people need it? Is it the most obvious thing everybody else will need it? If they need it, it exists. Don't go reinventing the wheel. And so in this particular case, there is index ID map. Wrap your index with the index ID map. Then you can search it by the ID that you give, because when you add things to it, create IVF, save index, forget it, add. Look at this. You can use add with IDs. You can give it a vector and you can give the ID or list of vectors and their IDs. Those IDs being whatever database IDs you use to identify that row, that chunk, right? It is as simple as that, guys.
Asif, question on that. Sorry, I'm okay. So the question is, you are the chunks sentence vectorizer. One at a time we are indexing, or we are indexing
list of it.
Multiple
vector list.
Multiple chunks.
You notice that I'm vector list chunk, multiple chunks. They embeddings. Remember, indexing you don't do on chunks. You do it on the vectors.
Question is like, is it happening on a bulk of document or one document at a time?
It doesn't matter. In my architecture, the way I did it is I took a document, all the documents in parallel, and I text extracted it. I saved the extractions into the database. One job done. This is the one compute job. If you look at this, so let me walk you through that in a moment. It's a whole new thought, but okay, I'll give you a high level and then I'll walk you through the code. I always divide my workload into small chunks. Remember, single responsibility pattern is my mantra. So one job just does text extraction and saves it in the database. The second job then takes the text and cleans and chunks it and saves the chunks into the database. The next job takes the chunks and each of them converts it into a vector, puts it back into the database. And the last piece of the puzzle, last part of the pipeline of my Jenkins pipeline is the indexer. I gave it in my design doc, if you notice. And
the question is that you pick up all the sentence, all the database rows and try to convert into the phase index.
Yes, of course. But the question is, do you send it sequentially? Do you send it in?
Do you send sequentially? Yeah, exactly. Incrementally.
So, what you do is, this is where the thing comes. See, you have to do good design. That's a very good question, actually. You have to do good design on two fronts. You have to do good design on the sending front. You have to be respectful that the GPU might get completely overwhelmed. You can't send it a million chunks, right? Simultaneously. There is no point. Most likely the receiving end, the server is going to queue it. But if you have no choice, go do it. If you trust that the receiving system will anyway queue it, no harm. Just go send it in parallel.
Hey,
At the receiving side, one second, Masmi. On the receiving side, what you need is, once you have the queued, what do? Now, but systems like Ray will do that for you. They will maintain the queue, all right? And a reasonably good queue. Though to be bulletproof, it is far better to have your own Kafka or such queues in front of those, just if you want to be absolutely bulletproof. But from the queue, you want to consume batches of data. Let's say that your GPU is 4090. You can take a batch of 32 vectors at a time, 32 chunks of text at a time and vectorize them. So you want to send chunks of 32 size through your GPU, right? Are you getting that, Prakash?
Yes, Asif. But I wanted to know, is it doing compaction at like incremental indexing and compaction, or is it what? Like,
see, incremental indexing is a norm, right? Data keeps coming in. But what I usually do, or I can tell you my practice. I maintain 2 replicas of an index. I don't ever do simultaneous indexing and searching. Generally, I don't consider that a great idea. What I do is, at every X number of rows, let's say 10,000 inserts or 1,000 inserts, based on the traffic, based on other considerations, volume, etc., I will materialize, I'll save a copy of the index. I will have a listener job, the one that is doing the actual search. That process will be listening for the latest copy of the index. The moment it finds a newer copy of the index, it will load that one and replace its current index with that. Right?
actually, in my implementation, I have a read index and write index.
Good.
So
that's what
for
you
a
should do.
query, I use read index.
Good. And the only thing you need to make sure is the guy who's serving your read index is listening for new copies of the read index.
Yes, and that's why I do like a minute-based rotation.
Now, don't do minute-based rotation because it may be unnecessary. Or make it insert-based. After X number of inserts,
Yeah,
you materialize it. Right? That way you don't waste
yeah.
it.
I mean, right now it's just ready very early, so I just tried
Yeah.
a minute-based.
Yeah, but that's a pretty respectable. You made good. Yeah, good that you're thinking about all these things. It's
Yeah.
really good. So, guys, do you notice that the rest of it is very straightforward? You index with the ID here, and I won't go into the. I mean, if you want, I can talk about more and more service, FAS, and query results re-ranking. Sorry, 1 second. No, I think Mosmi was waiting. Mosmi, go ahead.
Yeah. Thank you. So we talked about passing 32 chunks to the indexer, or n number of chunks to the indexer. Read it from the DB, pass it to the indexer, create an index. I didn't quite catch what you said about something to maintain the number or something.
No, what I'm saying is, Vasi, for example, look at your code. You remember that you are trying to store the insert row. If the row ID matches, what is the row? When you see FAS index, when you search for something, it returns the capital I. In your code, remember it, you see that capital D and capital I. The capital I is what? It represents the number which represents the insert order into the FAS. Right? That this was the 10th element inserted and this was the 106th element inserted.
Yep.
That's what it. So you are forced to store that into your database. Isn't it? In
What
fact,
is the point of having a face index then?
No, that is not the index. FAS index is it is for extremely fast searches of vectors. So imagine that each vector is a page in your book. Now, what happens when you read a massive textbook? You're looking for some concept. Where do you go looking for it? You go looking to the back of the book where there is a small index, a few pages of index pages, right? In the index, that concept is there and it tells you which page contains that. Isn't it? So a FAS index is not a collection of vectors. It is a collection. It basically tells you that if you're looking for something, which vectors are relevant. Just like an index of a book, textbook tells you if you're looking for a concept, which pages of the textbook are relevant. That is the meaning of index. Remember, always have the mental picture of a textbook in your mind. That will clarify the meaning of index. Masmi, I know where you're getting a little bit worried. Database indices actually arose from the same concept. I'll now relate it to what you think of as Oracle index. Oracle database index, since you come from Oracle background. See, suppose I was looking for Mosmi and the world has 8 billion human beings and I have no idea where it is. I would be searching everywhere. I would go to every continent and say, is Mosmi here? But suppose somebody whispers to me, one oracle, I go to an oracle, a magician, and the magician just says, I don't know, but I can tell you which continent Mosmi is on. MOSME is in the US, is in the American continent. Well, you come, you limited the scope, you come to US. Now you get another oracle there. And you say, oh, I've divined that MOSME is in California. Now you zoom into California. And then somebody tells you that, oh, she's in Fremont at this moment. You zoom into Fremont, and it becomes much more precise, funnel, targeted search for MOSME in the database. Yeah. That is why indices were created. Indices bring optimization, even in the Oracle database. That is the real meaning of index. And the same thing is here. A fast index it just gives you an extremely fast way of zeroing in and finding what you're looking for. The vectors you're looking for.
Yeah, but in Oracle database, I'm not saving the row number in the table.
No, you're saving something equivalent, just saving the offsets, the row, the row source offsets. Yeah. Locations on this, from where to start looking for, from where to do sequential scan, or sectors to do sequential scan of. Now, see, in an index, in an Oracle index, either you are pointed to the next Oracle, the next index, sub-level index, or you are pointed literally at the leaf level to a row source, to a collection, to an array, and your array of rows. And you're told that your answer is there in this small array of rows. Yeah. That is indexing.
Yeah, it seems to be doing a lot more work.
Yeah, I mean, it does a lot of work. Obviously, these are mature workhorses of the industry, but I'm talking at the level of a concept, very basic concept. Guys, please mute yourself. Yeah. So, Mohammed, did I answer your question? You got the idea, right? The FAST index is basically a way to search for vectors.
I got that.
Yeah, good.
So what happens if what I'm understanding is there's a heavy lifting that's going to happen. First time you load up 30,000 documents, then it's going to be incremental, right?
Yeah.
I'm just updating 2 or 3 documents in a month.
Yeah, which is why I told you that don't like, for example, Prakash said, he's going to make a copy of the index every minute or 3 minutes. Don't do that. Instead, do it for X number of inserts.
Yeah, 8 hours, whatever.
Yeah, or number of inserts. So use some heuristics, some meaningful heuristics. Okay, guys, so this is the re-ranker. Do you notice that all my code after a little while looks exactly the same? Right? And that adds to keep your code base simple, keep it dead simple to read and dead simple to understand. And most of you are familiar with my code. If there is one thing I hope you would agree, it is usually dead simple. I mean, there's no magic here. There's nothing hard. This entire project was not so much about doing deep AI, but learning the infrastructure, to build the infrastructure so that you can do interesting AI in the subsequent projects. Like, for example, this week's project builds upon what you have built so far. Right? When you do the image search, by the way, I must say that when I say image search, it means both ways. I can give you a dog and say search for the documents relevant to this dog, or I can give you a query and a straight text query, and in search results, I expect both images and text to show. That's your project. But I think if you follow this sort of a template or a way, it's one way of doing it. You may have better ways or you may have other ways.
Good question, Asif.
Yeah. Go ahead.
Yeah, so the phase index, are they distributed or are they only available on the server?
No, phase index is a file, remember. But the index have the mathematical property that they have some associative properties. They're additive, so you can maintain. Like I think you or somebody was using the word sharding of the index in multiple things. Don't shard, but you have the opposite of sharding. You have the ability to merge indices. Right? You can maintain sharded sub-indices. Doesn't quite help you very much, but merging index is very easy. You can, because indexing takes time. You could create
microservice architecture. You have a microservice. So index available only on that service?
No,
index is
no.
distributed?
It depends upon how you serve it, whether you use a distributed file system or a local file system. But when you are just reading an index and loading it in memory, remember, index is an in-memory object. You read it from a file and you're serving it from memory.
So, Asif sir, for that generating the FIAS index,
Mhm.
I understand it goes into one single file, but you are adding it among distributed workers in your model, or it's just one worker?
No. In my case, what I do is, see, one thing that you could do is if you create distributed workers, let's say that you create 3 workers, what will happen? They will end up with 3 different index files. That is fine, but you'll have the task of merging them. No, FAS gives you a very simple method to merge the indices. You can add another index to a current index. So then you have to follow it up with a merge process. In this sample code that I gave you, I kept things to extremely simple situation. I made the insert into a single index.
Okay. That makes it simple. Okay.
Yeah.
And then partition.
So,
Yeah.
Asif, quick question. So let's say if you have distributed service.
Yeah.
So the sentence vectorizer embedding goes into a different indexes, right? There is no one index which contains all the chunks.
In my case, I maintain a single index that contains all the chunks. Why would I maintain different indices?
And if there is a single index, sir, then there is a potential of that service will get a DOS attempts.
Absolutely. That's what I'm saying. That, see, your choices are this. At this moment, I just, as I mentioned, I've kept things very, very simple. So let's go to the REST service and see it. Where is my indexer service? FAS index builder service. Do you notice that I've set max replica to 1?
Yeah.
Right. Suppose I didn't do that. It's a choice. If you get heavy traffic, heavy data, what you could do is you could have, let's say, 3 replicas. Then what will happen? You should be aware that you will end up with 3 index files, each containing different data. You would agree, right? Because data is being distributed across 3 of the replicas for indexing. Means A will go to maybe replica 1, B vector will go to replica 2, and C vector will go to replica 3, right? Now, at inference time, you don't want to be searching 3 indices. What you want to do is you want to merge them into one single search index. So what will you have to do after this job finishes indexing? Somebody has to pick those index 1, index 2, index 3 and do what? Merge them. So that for inference time, for search time, you are searching a single index.
Yeah, but you don't have that service at present in your.
No, I didn't do that. I didn't do that. No. But if you want to do that, by the way, it's a one-liner, guys. It's one line.
Yeah, I mean,
but that won't be a service. It will be a backend job.
It's a distributed file system.
Not necessarily. It's not like that, Prakash. You don't need a distributed file system. All you need, imagine 3 files have gotten created. It could be on a single file system. It could be on a distributed. But what you really need is a way to merge them. And FAS gives you a simple command, a simple API to merge indices.
Okay. Yeah.
Okay, why would you merge them, Asif? Because you have to load the index. If you have a large index, you'll run out of memory, right?
Indices are never large. I mean, you can put the entire Wikipedia, and I believe the Wassersteins have done that. And I'm sure they're delighted at how small the index file eventually
so
is.
why do I still have to merge? I can still search against n indexes.
Yeah, you do, except that, see, here's the thing. Masmi, think about it this way. If I told you that Arunesh knows where you are, and I have to just go and ask Arunesh, hey, where is Masmi? He'll tell me. It's easy, quick. On the other hand, if let's say Arunesh has no idea, and because you happen to be at work, and you could be in any one of the 10 departments roaming around, right? Because your work takes you across 10 departments. I want to search for you. I will have to call the head of all 10 or some contact person in 10 departments and ask each one of them, is Masmi there? Is Masmi there? Right? So what happens? There is wasted effort. When you maintain 10 indices, you remember what will happen is when you do a nearest neighbor search, each 10 of them will come up with 10 nearest neighbors. right? Then you will have the problem of merging the search results at inference time. That significantly increases your runtime inference cost or search cost. And search is done at volumes, big volumes, right? High traffic systems. You want to minimize the amount of computation you do at runtime. How can you do that? By having just one person, one index that can answer who are the nearest neighbors to a given query vector. Am I making sense, guys? That is why it is good to spend most of your computations during the pipeline. Put it in your pipeline, data pipeline. You create multiple indices, then you merge the indices. It's a job. It's a tiny job, one-line job. But at the end of it, the merge will take time. Let's say it will take 5 minutes. But at inference time, you have lightning fast searches, especially because these index files get loaded to memory. And you have to realize that today's processors run at 6 gigahertz. And at 6 gigahertz, and they have a massive, massive bandwidth to the CPU, memory, and memory is near. When you search something in local memory, it is lightning fast, and you instantly get the results.
Got it.
Yeah.
So, don't you have to coordinate the Elasticsearch and the fetch index switching when you do?
Oh, yeah. So, okay. So such a good question. So remember, what we are building is a hybrid search engine, right? The state of the art is not vector search or Elasticsearch. It is hybrid search, which is what you guys are building. What does it mean? So now let's go to the real search, the endpoint user search. When an endpoint user searches for something, and I've deliberately left it as empty for you because I was going to share this code with you, what do you need to do? First of all, you will take the query vector. You will receive a query vector from the user. The user will say, send me the top 10 results. What will you do? You will go to Elasticsearch and say, give me top 20 results. You will also go to Fast Index and say, give me top 20 results. Now you have 40 results, right? You will mix all of those results up and give it to the re-ranking service and say, hey, find me the best results amongst the 40. Right? The cross encoder, the full transformer cross encoder will then apply the full power of a language model. But it's a very expensive job, but that job is doing by comparing a query vector against just 40 other vectors. 40 other, sorry, not vectors. You're getting 40 other text pieces, isn't it? And that is a price worth paying to get better accuracy, better recall, better precision. And that's why these are the steps. Get the results from Elasticsearch, get the results from Fast Index, then send it through the re-ranker, return the results. That's it. Merge. Sachin, is that making sense?
You answered this question, but my question intent was slightly different. Is when you have indexed the same article in the Fast and Elastic, then only you will, when you switch the indexes, right? Say the Fast index is switching, don't you have to coordinate with the Elasticsearch also, like making sure that the document is there in Elastic and Fast at the same time, right?
See, what you're getting at is every time you insert, you have to make sure you insert in both places, Elastic as well as Fast. That absolutely is correct. So when your data pipeline, every document must be indexed twice, Elastic as well as Fast. It makes sense, right? Otherwise, both of them should get a chance to look for it. So that is done. Now, your secondary question is, what if I change the underlying algorithm behind Fast? Instead of going with, for example, flat L2, I go to HNSW. Well, then that's your internal problem. You need to rerun your Fast indexer, right? On all the documents. So all the documents must exist in Elasticsearch. All the same documents must also exist or be indexed into the Fast index. Now, did I answer that, Sachin?
Yes.
Good. So that is it, guys. So this is it. I'll release this code at some point today, but I hope you got the idea of how to go about it. And now I will take a half-an-hour break, and then we would like to start the presentations from each of the teams. So guys, bring your notebooks. I want everybody's votes. And remember, you're voting on the rubric. The rubric is completeness, quality of the models, or the way the thing has been done, beauty of the AI, performance and scalability. Well, I know that most of you haven't completed, but at least we can speak to that, and other people can then ponder over how well you have addressed those issues. Right. So the rubric is there on the Slack. Please use the rubric. Be ready. In half an hour, we'll start those presentations. Any other questions, guys, before I close this help session?